Throughout human history, scientists have struggled to understand what they see in the night sky. Famous astronomers, many of them great scientists who mastered many fields, explained the heavens with varying degrees of accuracy. Over the centuries, a geocentric view of the universe, with Earth at the center of everything, gave way to proper understanding we have today of an expanding universe in which our galaxy is but one of billions. On this list are some of the most famous scientists from the early days of astronomy through the modern era and a summary of some of their achievements. After 14 centuries, since Ptolemy, 5 noted scientists made important discoveries that gave rise to the birth of modern astronomy. These were Nicolaus Copernicus, Tycho Brahe, Johannes Kepler, Galileo Galilei, and Isaac Newton. Nicolaus Copernicus is a revolutionary astronomer who challenged the prevailing geocentric model of the universe and proposed a heliocentric system. So ano nga ba ang heliocentric system? It is a theory that places the sun at the center of the solar system. Copernicus spent decades meticulously observing the heavens, studying the movements of the planets and the stars. He realized that a simpler explanation for these movements could be achieved by placing the sun, not the earth, at the center of the universe. This heliocentric model, which he developed independently of the ancient Greek astronomers, Aristarchus of Samos, proposed the Earth was a planet that revolved around the Sun along with the other known planets. So nakasaad dito na ang araw daw ay hindi umiikot sa Earth at sa iba pang mga planeta, kundi ang Earth at ang iba pang mga planeta ang mismong umiikot sa araw.
Tycho Brahe was a Danish astronomer and nobleman who made accurate observation of the movement of celestial bodies in an observatory built for him by King Frederick II of Denmark in 1576. He was able to invent different astronomical instruments with the help of his assistants and made an extensive study of the solar system. He was able to determine the position of 777 fixed stars accurately. Ang mga nagawa ni Tycho Brahe ay gumawa siya ng tumpak na mga obserbasyon sa mga bituin at planeta. Ang kanyang pag-aaral sa bagong bituin na lumitaw noong 1572 ay nagpakita na ito ay mas malayo kaysa sa buwan at kabilang sa mga nakapirming bituin na itinuturing na perpekto at hindi nagbabago. Johannes Kepler. When King Frederick II died and the successor did not fully support Brahe's work, he moved to Prague in 1599, where he was supported by Emperor Rodolph II and worked as an imperial mathematician. Emperor Rodolph II recommended Johannes Kepler to work for him as an assistant. Kepler was born to a poor German family and studied as a scholar at the University of Tübingen in 1589. Si Johannes Kepler naman ay gumamit ng simpleng matematika upang bumalangkas ng 3 batas ng paggalaw ng planeta. Ang unang batas ni Kepler ay nagsasaad na ang mga planeta ay gumagalaw sa mga elliptical path sa paligid ng araw. Natuklasan din niya na ang mga planeta ay gumagalaw ng proporsyonal ng mas mabilis sa kanilang mga orbit kapag sila ay mas malapit sa araw. Ito ang naging ikalawang batas ni Kepler.
Law of ellipses revolutionized our understanding of how planets move around the sun. It states the orbit of a planet around the sun is not a perfect circle, but rather an ellipse with the sun at one of its 2 foci. Ellipse is a closed curve that is defined by 2 points called foci. The sum of the distances from any point on the ellipse to the 2 foci is always constant. The sun occupies one of these foci while the other focus is empty. Kepler's Second law of planetary motion, also called as law of equal areas, it describes the relationship between a planet's speed and its distance from the Sun. It states that a line segment joining a planet to the Sun sweeps out equal areas in equal intervals of time. Imagine a planet orbiting the Sun in an elliptical path. As the planet moves along its orbit, its speed changes. The law of equal area states that the area swept out by the line connecting the planet to the Sun is always the same for equal time intervals. This means that when the planet is closer to the Sun, it moves faster, covering a larger distance in the same amount of time. Conversely, when the planet is farther from the Sun, it moves slower, covering a smaller distance in the same amount of time. Last but not the least is the law of harmonies. It states that the square of a planet's orbital period is directly proportional to the cube of the semi-major axis of its orbit. The law of harmonies applies not only to planets in our solar system but also to moons orbiting planets and even artificial satellites orbiting Earth. Astronomers use the law of harmonies to study exoplanets, planets orbiting stars outside our solar system. By observing the transit of an exoplanet across its star and measuring its orbital period, they can calculate its average distance from that star.
Brahe and Kepler's work. Brahe and Kepler had an unsteady working relationship. Kepler was Brahe's assistant. However, Brahe mistrusted Kepler with his astronomical data in fear of being shadowed by his assistant. Brahe assigned to Kepler the interpretation of his observation of Mars, whose movement did not match Brahe's calculation. Kepler was tasked to figure out what path Mars followed as it revolved around the Sun. It was believed by many scientists that Brahe gave this task to Kepler to keep him occupied and left Brahe to develop his laws of planetary motion. Kepler's discoveries from Brahe's data. Kepler postulated that there must be a force from the Sun that moves the planet. He was able to conclude that this force would explain the orbit of Mars and the Earth, including all the other planets, move fastest when it is nearest from the Sun and move slowest when it is farthest from the Sun. Eventually, Brahe decided to give all his data to Kepler, hoping that he would be able to prove his Tychonic system and put together new tables of astronomical data. This table was known as Rudolphine table, named after the Roman emperor, and was useful in determining the position of the planets for the past 1,000 years and the future 1,000 years. This table was the most accurate table that is known to the astronomical world. After Brahe died in 1601, Emperor Rudolph II assigned Kepler as the new imperial mathematician, and all of Brahe writing instruments and the Rudolphine tables were passed on to him from Brahe's data. Kepler was able to formulate his laws of planetary motion, the law of ellipses, the law of equal areas, and the law of harmonies.
Galileo Galilei is considered as the father of observational astronomy, modern era classical physics, scientific method, and modern science. Galileo was not the first to build the telescope, but he was the first to use it for astronomical observations and publish his findings. He discovered the Milky Way is composed of stars, the Moon has mountains, and Jupiter has 4 moons. He also observed the phase of Venus, which supported the heliocentric model of the solar system. Isaac Newton. Newton's 3 laws of motion are fundamental to understanding the motion of celestial objects. Newton's law of universal gravitation remains a cornerstone of modern astronomy, providing the framework for understanding the motion of planets, stars, galaxies, and even black holes. Newton's work provided a theoretical foundation of Kepler's empirical laws of planetary motion. Newton's three laws of motion. The first one is called the inertia. This law states that an object at rest will remain at rest and an object in motion will continue in motion with a constant velocity unless acted upon by a net external force. For example, a ball sitting on a table will stay there unless someone pushes it or something knocks it over. Newton's second law of motion is called acceleration. This law states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. So, for example, pushing a box requires more force to get it moving than pushing a lighter box. The third law of motion is called the law of action and reaction. This law states that for every action, there is an equal and opposite reaction. This means that when an object exerts a force on another object, the second object exerts an equal and opposite force back on the first object. For example, when you jump, your feet push down on the ground, and the ground pushes back up on your feet with an equal and opposite force propelling you into the air.